Functions and graphs, maxima and minima. Find the minimum value for the function fx is x squared minus 2x minus 8. Note that minimum and maximum points, also called turning points, occur when the slope of the graph is 0. In other words, where the graph is horizontal. These points occur when f dash x, or dy dx, equals 0. So let's find the slope now of the function fx is equal to x squared minus 2x minus 8, or y is equal to x squared minus 2x minus 8. So if y is equal to fx equals x squared minus 2x minus 8, we can differentiate it. The dy dx, or the f dash x, is as follows. Differentiating x squared, we take the 2 down and it becomes 2x. With the differentiation of minus 2x, we get minus 2. The x component just falls out. And differentiating a constant gives you 0. So dy dx, the slope of this function, is always 2x minus 2. We're interested, though, in when the derivative of the function, or the slope of the function, equals 0. So we're going to set this 2x minus 2 equal to 0. So when is 2x minus 2 equal to 0? Well, when 2x equals 2, putting the 2 on the other side. If 2x is 2, it's when x is 1. So we can now find the value of the original function when x is 1. So the original function was fx is x squared minus 2x minus 8. And substituting in the value of 1, we get 1 squared minus 2 times 1 minus 8. And doing the arithmetic, we get 1 squared is 1, minus 2 by 1 is minus 2, and the minus 8 transfers down. And 1 minus 2 gives minus 1, minus 8 gives minus 9. So when x is 1, the y value, or the f of x, is minus 9. So there's a local minimum at the point xy equal to 1 minus 9. And if we were to draw the graph, we would see the graph is a quadratic. It comes down and goes up, so it only turns once. That's a minimum point, and it's at the point 1 minus 9. Nowhere else is the f dash x equal to 0. Nowhere else is the function at that stage, the slope of it, horizontal. So let's look now at the lines intersecting the graph. For what values of k does the function y equals fx equals k intersect the function twice? So this is quite complicated in expression, but y equals k is just y equal to a number. Y equals 0, y equals 1, y equals 2. And y equals 0 is the x-axis. So y equals 1 is just a line above the x-axis parallel to it. So let's look at the observation and say when and for what values of k does the y equal to k line cut the function twice. So here's our original function, and here's a whole series of y equal to k lines. Y equal to 4, y equal to 1. Let's take the y equal to 0 line. Y is 0 here, 0, 0, 1, 0, 2, 0, 3, 0. Y is always 0. In this case, for the y equals 1, it's not 1, 1, 1, 2, 1. So y is equal to 1. And if we take the series of lines, we can see y is 4, cuts the graph twice. Y is 1, cuts it twice. Y is 0, cuts it twice. Y equal to minus 2. All the way down, we continue to cut the graph twice. But not here. At y equals minus 12, this red line doesn't cut the blue graph at all. So it's clearly that line doesn't cut it. And the lowest line that cuts it at all is this y equals minus 9, the point of the minimum, the 1 minus 9. So points above this would cut the line twice. So in effect, by observation, all horizontal lines parallel to the x-axis above the line fx equals minus 9 intersect the original function twice. So the answer they were looking for was k greater than minus 9. So provided that you're up above the minus 9 at minus 8, minus 7, or even minus 8.5 or close to minus 9, you're going to cut that graph twice. So k greater than minus 9.